Okay, so now we're going to look at this next situation here where we have, suppose the sine of an angle in degrees is equal to 5 over 13. Find cosine n and tangent n without using a calculator or anything like that. Okay, well, if you know one trig function of an angle, even if you don't know what the angle is, you can find the other trig functions. Because if you think about it, if the sine of some angle, whatever it may be, is 5 over 13, that means that if you had a right triangle with that angle in it, then opposite over hypotenuse would be 5 over 13. All right, if I want to find the cosine of that angle, I would do adjacent over hypotenuse. Well, I don't know what the adjacent side is yet, but I can find it by using the Pythagorean theorem. So if this were x, I could say 5 squared plus x squared equals 13 squared. So 25 plus x squared is equal to 169. So x squared would be 144, and x therefore would be 12. So I know that this other leg is 12. So now I can write out cosine n equals adjacent over hypotenuse, 12 over 13. And tangent n is going to be opposite over adjacent, so 5 over 12. So I'm able to find the cosine and tangent of an angle just by knowing the sine, and I could do that without ever even knowing what the angle is, just by drawing a triangle and filling in the legs, because these are all just ratios of the lengths of the legs. All right. So now we're going to start looking at some applications of these trig functions. What are they used for? One of the main things that you can use trig functions to find are distances. So depending on your situation, you use two things called angles of depression and angles of elevation, and these are really important. It's really important to understand what it means because it's easy to not get it. So let's just make sure we know what these two words mean. So suppose we have an operator at the top of a lighthouse, and he sees a boat down on the water. Then it says that he sees a sailboat on a line that makes a 2-degree angle with a horizontal line from where he is. The angle between the horizontal line and this line of sight is called an angle of depression. So this angle right here is called an angle of depression. And the reason it's called that is because if you're up here on top of the lighthouse and you look out, straight out, and make a horizontal line, okay, straight across, left and right, straight, horizontal, and then you make an angle down from the horizontal to this line that goes down to the boat, then that is called an angle of depression. It goes down from the horizontal, so depression, down. It goes down from horizontal, all right, 2 degrees, they say. This angle they're calling an angle of elevation because you're down there at the boat and now your horizontal is the ground or the water. So you have this horizontal line going out left and right, and then you're going up from that horizontal line. So you're elevating up from horizontal. Whenever you're finding an angle of elevation or depression, one of the sides of the angle is going to be horizontal. All right, because you're either going up from horizontal or you're going down from horizontal. All right, so now we can use this information to figure out how far the boat is from the lighthouse. So if you were in the lighthouse and you were trying to figure out how far away the boat was so that it might not hit the rocks or whatever, and you know how much time it's got left or whatever, then you might want to know that distance. So the distance from the boat to the lighthouse is going to be this right here. The height of the lighthouse, we know, according to this, is 25 meters. So if the top of the lighthouse is 25 meters above sea level, the distance x between the boat and the base of the lighthouse can be found. All right, so the height of the lighthouse is 25. And then the distance from the bottom of the boat to the bottom of the lighthouse is x. So we have this right triangle that's been created with the line of sight from the boat up to the top of the lighthouse being the hypotenuse. And since we know this angle of depression is 2 degrees, we can use the tangent function to find that missing distance. All right, so the tangent of 2 degrees is going to be opposite, which is 25, over adjacent, which is x. So you've got that 2-degree angle of elevation. The adjacent side is x. The opposite side is 25. You've got this big right triangle here. All right, now you've got to be careful here because you can't multiply both sides by 25 in this case to get x by itself, because 25 is not in the denominator. X is in the denominator. So when your unknown is in the denominator, multiplying both sides by 25 is not going to give you any help. It's just going to make things worse. You're going to have 25 tangent 2 degrees equals 25 times 25 over x. Okay, that doesn't help. So what you have to do is you can think of it as tangent 2 over 1 times 25 over x, and then you can cross multiply. So you would get x times tangent 2 equals 25 times 1, or 25. And then to get x by itself, you're going to have to divide both sides by tangent 2. So it takes 2 steps now to get x by itself. And that way, that will cancel, and x is just equal to 25 divided by tangent 2. So now you've got to punch this into your calculator. You're going to hit 25 divided by, now you've got to do the tangent of 2. With my calculator, you hit the 2 first, and then you hit the tangent. All right, so then you hit equals, and it tells you about 716 meters from the lighthouse.